Hi. It's me, Bruce, and I'm here. Welcome to my channel. Thank you for clicking if you clicked. Thank you for not clicking if you didn't click and you end up being stuck with this anyway, but notwithstanding that, thank you. I appreciate what little audience I have. Okay, so right now I'm going to talk about something that has a fancy word. I'm going to write it down. I don't know if you can see this. That word is Exergy. Exergy. What Exergy is it's the difference between, this is a system or thing, and I'm going to get a different color, and the surroundings. Okay. So, here we have it. This is the thing, okay? This is the thing that has the exergy. This is the surroundings that sort of begets the exergy. You could make a more nuanced or complicated explanation. You could say, well, it could go both ways because you can bring the surroundings in equilibrium with the thing, or you could bring the thing in equilibrium with the surroundings. But either way, that's it, exergy. Okay, now, why am I talking about this? Because the other thing that what I'm really talking about, or it's a veiled conversation, is this thing called CCS, okay? CCS, carbon, capture, storage. The storage, okay? Carbon, capture, and storage. All right. Now, carbon capture and storage is this idea that the CO2 and the greenhouse gas emissions that people are producing that make their way into the world can magically be made into the world, can be extracted from the atmosphere and stored, captured and stored, so that it's not a problem. Well, let me tell you, okay, just in case you're wondering, carbon and greenhouse gases, that's a really huge problem. And, you know, I want to do a better job of explaining some of the ways that is a huge problem. But if you want to see the magnitude of the problem, you look no further than the Atlantic Ocean. Look no further than the rising of the Pacific Ocean, the rising of the oceans in general. Look no further than the strength of the hurricanes that have been pummeling the east coast of Canada. Go figure. Canada is not like the hurricane thing that first pops to mind. Look no further than when you step out your door in New York City. Are you in New York City? If you step outside your door in New York City and you're encountered yellow haze that is coming from fires, those fires are in Canada. The fires are magnified by greenhouse gas emissions and the fact that the forest is drier, desiccated. The atmosphere is hotter. It's more combustible. You have more drama. Okay, but on this for a second here. Carbon capture and storage. I'm talking about Exergy. What Exergy is the difference between your system, the difference between your thing and the surroundings. Okay. Now let's imagine that this crayon box was filled with gasoline. Okay. And this gasoline is at this level. You're holding it up high, all right? So the gasoline is being acted upon by gravity. So the first kind of exergy, you bring it into equilibrium with surroundings, is you drop it, it lands, and there's been some energy released in the form of this gravitational potential energy has been now, but we're talking about gasoline, okay? Now, before it became gasoline, there's a whole lot of things that had to happen, and all of those things are horrible for our world. But the mere fact that it exists, that means that it will combust. Okay, that the gasoline will combine with the oxygen molecules that exist in our atmosphere. And the long chain carbon molecules that are gasolines, like C to the N, H to the 2N plus 2 molecules, and they will CN means there's N carbon atoms in the molecule, and H means there's hydrogen, and there's twice as many plus 2 carbon atoms as there is hydrogen loosely. I mean, if you want to be a full-on organic chemist, maybe you could make a better, more detailed explanation, but for our purposes, that's good enough. So you're going to take that, and you're going to break this gasoline molecules apart. They're going to combine with the oxygen molecules from carbon dioxide. The hydrogen molecules will combine with the oxygen molecules. They're going to form H2O, water. Go figure. And what that does is it blankets, just accumulates in the atmosphere. Okay. And then in the act of combusting the gasoline, I have my magic crayon box container. In the act of combusting that gasoline, which means you're combining it, you've brought the gasoline into, let's say, equilibrium with the environment. And so the available exergy in a system or in a thing is the measure of the energy that is available. Availability is another word for exergy, but I find the word availability even more confusing. You're bringing your item into equilibrium with the surroundings, okay, and that's where the energy is being released. Now, if you think of a hydroelectric dam, so you're taking water that is at an altitude, and you're bringing it down to another altitude, you're bringing it into equilibrium with the surroundings, and that gravitational potential energy is being captured in terms of electricity. Electricity is kind of good. Electricity is a currency in the same sense of money is a currency. It's a medium of exchange. You're exchanging an energy source for a utility, for something that you want to do. Okay, so that's what electricity does. Hydrogen will do the same thing, but the hydrogen question has a lot more asterisks and fine points and yabbits. I had a whole video. I made a video about yabbit. Yeah, because you're going to explain something to somebody and they're going to go, yeah, but what about? Okay, so if you got a yabbit, please leave it in the comments down below. What I'm saying is that this idea of carbon capture and storage intertwined with the idea of exergy, and the reality is that for humans to have accumulated this much carbon dioxide and greenhouse gases in the atmosphere, we've burned a lot of stuff. And this idea that you can put that toothpaste back in the tube, which you can't do. That's like the classic example. That we're going to take the carbon from the atmosphere. We're going to expend a massive amount of energy to do that, and then where's that energy going to come from? And then we're going to put it back. That carbon's going to get put back in the box. We're going to put the genie carbon back in the bottle. Not going to happen. Okay. Now, someone's going to say, well, is it even possible to do this? The answer is yes, you can do it. You can remove carbon dioxide from the atmosphere and you can store it. It is possible. Okay. Is it possible on anything beyond an experimental scale? Really? No. Right? You can do it at an industrial scale, like a massive scale. We can have hundreds of hydroelectric dams and hundreds of nuclear power plants and hundreds of wind turbines and hundreds of square kilometers of photovoltaic cells, all capturing non-emitting energy, and we're going to use that energy to extract the carbon from the atmosphere and return it back to where the level of carbon back to where it was, say, at about 1850. Can you do that? Can you? Can is one of these things. It's like, yeah, can you? Well, of course, yes, possible. But can you really? No, it's madness. And the amount of, and if you're going to produce all this vast amounts of energy and use it to extract that carbon dioxide, and worse yet, the methane that's been emitted into the atmosphere, you're going to extract that and put that back in the bottle. I'm suggesting that you're ahead of the game by simply just use electricity. For all those things that we do today with whatever method of energy that we're using, whatever energy that you're using right now that is not electricity, just use electricity. And it works in almost every use case. And there's a couple that makes it more difficult. But transportation, can we electrify all of our transportation in the world? Yes, we can. Okay. Can we make our houses comfortable with electricity? Yes, we can. Can we cook our food with electricity? Yes, we can. Can we... You get it? The answer is yes, we can. Electricity. Now, this idea is we have carbon capture and storage, Exergy, which is like a kind of a manifestation of the third law of thermodynamics, and it's the big reason why the carbon capture and storage thing is for me, and really it's a no. Okay. Now, people are going to advance this idea of carbon capture and storage because it's a seductive thing, right? It just sounds great. Let's do it. Let's just get rid of all the carbon stuff that we've emitted and we'll put it somewhere. Well, yeah, I can understand why that's a seductive thought, but just because it's seductive and appealing and you think that it sounds good, let's do it. Sometimes the sounds good, let's do it is no. And my good friend, who's actually not my good friend, Mr. Albert Einstein. Well, Mr. Albert Einstein said, and I'm paraphrasing because I wasn't there when he said it, but reportedly he has said that you want to make things as simple as possible and no more simple than that. Okay? So this idea that you can capture carbon and store it in the ocean, or you can store it in a mine, or you can store it in crystals, or you can jam it back down a well, or it's all exactly, precisely, it's a hard no. You can do it as a little, and when I say little, I mean little is a relative thing. Like you can do it on the scale of a classroom. You could have a university laboratory level experiment where you're capturing some capturing some carbon dioxide from the room and you're storing it somewhere. Can you make that work? Yes, you can. You have to use a tremendous amount of energy to do it. Okay, the next level up. Can we make one that's 1,000 times bigger than that and use it as a demonstration for industry, as a method of attracting investors and getting government funding and public resources directed at this folly? Can you do it at that scale? Yes, you can, for sure. Now, can you do it at a scale where it's going to make a fiddler's toot of a difference to the world? No. You can't. Doesn't work. Okay. Period. I mean, it's like this video, my videos of this channel. I have the least. I mean, hardly anybody watches these. I get it. And of all the people that watch them, probably almost no one watches the whole thing or pays attention. And of all those people that don't pay attention, or the one person that does pay attention, if I convince one person of something, is that enough to affect the world? Well, I hope so. But really, but the point is that education matters. And so I encourage education at the base level. And if you find yourself in the middle of a class where someone in your class or even you is tempted to raise your hand and ask the instructor to say, hey, what's the point of learning this anyway? If you feel the need to ask that question, well, then I assure you that the point of you learning this material is because it's tremendously valuable to humanity. And please pay attention. Do your homework, practice, do more than your homework, and it will all work out. Anyway, okay, my name's Bruce. I get it. The videos are long and long-winded, and there's not a lot of really, really sexy B-roll and all that stuff. And but I'm me. I know what I am, and this is what I can do. All right, and I thank you. Okay, bye. Please leave a comment, smash the like button, and subscribe to the channel. You can be my my goal. Here's a goal. I'd like to get 75 subscribers. Okay, if you can help me get to 75 subscribers, woohoo! Thank you very much. All right, bye now. Put my crayons away. I take my crayons and go home. Oops, that crayon broke. Got a broken crayon. That's no good. All right.